Greetings from EduAspirant, our YouTube channel for academics, competitive and entrance exams and enrichment of knowledge. In this chapter, Chemistry 6, we will learn oxidation-reduction reactions. Classical concept. According to classical concept, oxidation may be defined as a process which involves the addition of oxygen or any other electronegative element, or as a process which involves the removal of hydrogen or any other electropositive element. For example, copper plus oxygen gives copper oxide. Here, addition of oxygen takes place. H2S plus O2 gives sulfur plus water. Here, removal of hydrogen takes place. Sodium plus chlorine gives sodium chloride. Here, addition of electronegative element chlorine takes place. Reduction may be defined as a process which involves the addition of hydrogen or any other electropositive element, or as a process which involves the removal of oxygen or any other electronegative element. Example, H2S plus Br2 gives 2HBr plus sulfur. Addition of hydrogen takes place. Copper oxide plus hydrogen gives copper plus water. Here, removal of oxygen takes place. Oxidizing and reducing agents. Oxidizing agent is a substance which gives oxygen or gains hydrogen. Reducing agent is a substance which gains oxygen or gives hydrogen. Copper oxide plus hydrogen gives copper plus water. Copper oxide has given oxygen, hence it is oxidizing agent, while hydrogen has gained oxygen, hence it is reducing agent. An overall reaction which involves both oxidation and reduction simultaneously is called redox reaction. Here, Fe2O3 undergoes reduction, give iron, while carbon monoxide undergoes oxidation, gives CO2 gas. Electron transfer concept of oxidation and reduction. Oxidation may be defined as a process in which an atom or an ion loses one or more electrons. Oxidizing agent is a substance which can accept one or more electrons. Reduction may be defined as a process in which an atom or an ion gains one or more electrons. Reducing agent is a substance which can donate one or more electrons. H2 plus F2 give 2HF. Here H2 loses 2 electrons, therefore it is oxidation reaction, while F2 gain 2 electrons and therefore it is a reduction reaction. And redox reaction, oxidizing agent is reduced by accepting electrons and reducing agent is oxidized by losing electrons. Zinc loses 2 electrons, converted into zinc 2 plus ions, while copper 2 plus gain 2 electrons, converted into copper solid. Types of redox reactions. There are 4 types of redox reactions. Combination redox reactions are those in which either one or both the reacting species are in the elemental form. For example, iron plus sulfur give iron sulfide. Here, both iron and sulfur are elemental form. Decomposition redox reactions are those reactions in which either one or both the decomposition products are in the elemental form. For example, potassium chlorate on heating give KCl and O2, in which O2 is in the elemental form. All decomposition reactions are reverse of combination reactions, but all decomposition reactions are not redox in nature. For example, decomposition of calcium carbonate to give calcium oxide and carbon dioxide. Since in this reaction, both the products are not in the elemental forms, therefore it is not a redox reaction. Displacement redox reaction are those reactions in which an atom or ion in a compound is replaced by an atom or ion of some other element. They are of two types: metal displacement reactions, in which more reactive metal displaces a less reactive metal ions from its aqueous salt solution. For example, zinc plus aqueous copper sulfate give zinc sulfate aqueous plus copper. Non-metal displacement reaction, in which a metal or a non-metal displaces another non-metal from its compound. For example, sodium plus water gives sodium hydroxide plus hydrogen gas, and chlorine plus potassium bromide give potassium chloride plus bromine. Disproportion reactions. A reaction in which the same species is simultaneously oxidized as well as reduced. For such redox reaction to occur, the reacting species must contain an element which has at least 3 oxidation states. For example, the decomposition reaction of hydrogen peroxide is a disproportionation reaction where oxygen atom has -1 oxidation state in hydrogen peroxide, increases to 0 in oxygen gas, and decreases to -2 in water. This is the example of disproportion reactions where H2O2 undergo oxidation, give water and oxygen gas, while it also undergoes reduction to give water and oxygen gas. Effect of oxidation reaction in everyday life. There are number of oxidation reactions taking place around us which affects our everyday lives. The following are some examples of oxidation reactions. Respiration is an oxidation reaction. During respiration, food is oxidized to produce energy. Combustion or burning is an oxidation reaction in which energy is always produced. For example, burning of coal, natural gas, petrol, LPG, etc. Oxidation has damaging effect on metals as well as on food. The damaging effect of oxidation on metals is a corrosion, and that on food is rancidity. Corrosion is the process of slowly eating up of the metals due to attack of atmospheric gases such as oxygen, carbon dioxide, hydrogen sulfide gas, water, vapor, etc. on the surface of metals. Few examples of corrosions are the rusting of iron due to the formation of rust, chemically hydrated iron oxide, tarnishing of silver due to the formation of black silver sulfide, and the appearance of green color of basic copper carbonate on the surface of copper objects. Corrosion of iron, that is rust. Corrosion of copper because of formation of basic copper carbonate. Rancidity. Rancidity is the process by which fats and oils in food degrade, resulting in an unpleasant taste, smell and texture. It is caused by the oxidation of unsaturated fatty acids in food, which can be accelerated by exposure to air, heat and sunlight. Methods used to prevent rancidity. By adding antioxidants like butylated hydroxyanisole (BHA) and butylated hydroxytoluene (BHT) to the food items. Antioxidants are usually reducing agents. They destroy the free radical formed and prevent the oxidation of food. By packaging fat and oil containing foods in nitrogen gas, by refrigeration of foodstuffs, by vacuum packing, by storing food in airtight containers. by storing food away from light. This brings us to the end of our video on oxidation reduction reactions. Thank you.